Hello everyone, welcome to my channel. My name is Solo Anch, and in this video we're going to solve this problem right here. So we suppose that a and b are real numbers, okay, such that this line y equals to x plus b intersects this curve y equals to x squared at two distinct points a and b. Good. Now if the coordinates of the midpoints of a and b are that, okay, that is the coordinates are 5 for the x and then 101 for the y, compute a plus b. Okay, so this question is from the Harvard MIT Math Tournament, November 2023. Okay, it's a question 4 from the general round. Good. Okay, so let's start off with solution, just with faith. All right. Okay, so take note of the word intersect. So when do we say two curves intersect? Well, when they are equal. So we're going to find the points where the two curves are equal. So we're going to start off by setting the curve, that is the line x plus b, set it to the curve x squared. Good. So we're going to solve for the value or values of x that will make this equation true. And that this right here is just a quadratic. So you're going to write it that is x squared minus x minus b equals to 0. Okay, so if we've written the quadratic, okay, this is what we have. So we're gonna well, we don't have to, but if we solve for the values of x that will make this true, so let's assume that the solutions are, so let x1 and x2 be the roots, okay, in other words be the solutions. That tells us that for the x1, the corresponding y1, okay, will be the square of x1. Why is that? So when we get the value or values of x that will make these two equations true, okay, that is make these two curves equal, that means that the corresponding y value will just be either we use this or we use that. So I prefer to use the second equation, which will be the square of the x value. Then the corresponding y2 will be the square of the x value, which will be x2 squared. Okay, so without solving, that's what we assume. But again, notice that since this right here is a quadratic equation, this right here is always known to be the sum of the roots, while this right here is known to be the product of the roots. So let me just put product. Okay, that is for product. Good. So taking note of that, that means that so what I've just written out there tells us that a right here is the sum of the roots. That will be a will be the sum of the roots x1 and x2. That will be x1 plus x2. While b is going to be the product of the roots. So well here is not just b, this is negative b. So yeah, here I was careful by taking only a. This is negative b is the product x1 x2. I think that's the Vieta's formula or something, so if I'm not mistaken anyway. Okay, so these are the two equations. So let me just give these names and then maybe equation 2. Okay, so let's continue. Notice that using the fact that the coordinates of the midpoints of those two points of intersection are given, okay, they are given as 5 and 101. So we're going to make use of that fact. So how do you find the coordinates of a midpoint? Well, to find that, we just have to take x1 plus x2 divided by 2. That will give us the x coordinates of the midpoint. Then the y coordinates will just do the same thing, but using the y values divided by 2 as well. Good. So this right here should give us, from this should give us 5, while this one will give us 101. Okay, so from what we've seen here, okay, let's set this equals to 5 from the given information. So this is 5, while we set this to be 101. So from the given, that means that x1 plus x2, which we've called a from equation 1, okay, so that is a. That is x1 plus x2 is the same thing as, maybe let me divide it by 2 to show you what I mean. This is equals to 5. So this is a over 2 equals to 5, which tells us that a is 10. Good. Okay, so over here, well, y1 plus y2 is this. So y1 plus y2 is, well, if we divide that by 2, we get 101, which means to clear that, we just gonna have this to be 202. But well, y1 is x1 squared and y2 is x2 squared. Okay, so that is equals to 202 from the equation. Sorry, let's write that well. That is x2 squared. Okay, that is equals to 202 from the equation. Good. So we're going to rewrite this a little bit using some algebraic relations. So this is going to be x1 plus x2 squared. Okay, good. Divide subtract 2x1 x2 from that. So this is equals to 202. But this is known to be a. All right, the value here is a, which is equals to 10. So this is a equals to 10. Good. And then this right here, this negative sign together with these two will give us b. Sorry, yeah, take note of that. That is from equation 2. B is equals to negative x1 x2. So negative x1 x2, we can replace that with b. That means here we're going to have a squared minus 2b. Sorry, that will be plus 2b rather, because b has taken the minus. Okay, so that's what I'm trying to say. That's plus 2b. Okay, we equate that to 202. Good. Okay, but a is known to be 10. That means we're going to substitute that. We're going to have 100 plus, let me shift this up a little bit. So that's going to be 100 plus 2b, which we want to find is 202. So we subtract 100 from both sides, means that b is 102. And then b becomes, well, divide both sides by 2, 51. Good. So that means a is 10 and then b is 51. So we can find a plus b as 61, and that answers the question. Good. Okay, that was a cool problem from the Harvard MIT mathematical tournament. Okay, I hope you enjoyed the video. Please don't forget to share the video with your friends, subscribe to my channel, come back to our channel to see more videos. All right, okay, thanks for watching anyway.